Hey guys, so I want to start this unit by saying that this unit is going to be a little bit different. It's going to be kind of short, but it's also one that I've been putting off until the end just because it would be so much easier to do it in person. And the reason for that is we're going to be looking at regression, which you really need a TI-84 for, but I'm trying to find different ways that we can do it using online resources. So I have a few of those set up for you, and we'll be getting to that. But I also want to say that since not everybody won't be able to follow along the same way because I don't know what you have at home to be using, then I'm going to probably be making a lot of videos for this unit just because I can't effectively teach it live or make notes for it because it's going to have to be different for everyone. But we're going to go ahead and get started with that. So we're going to start by reviewing exponential regression, and the way that I'm going to show it on here is doing it in the calculator so that you guys can see the steps again and get a refresher on that. And so I'm going to pull up my calculator here, and to enter the list, you would go to Stat, and then click Enter on Edit, and then it'll pull up L1 and L2 for you. So you'll enter your X values in L1 and your Y values in L2, and I'm going to go ahead and do that so you guys don't have to watch it. Okay, so I got all of that. No, I didn't get all of that entered. I didn't press enter on 4.9. I got all of that entered now. And then I'm just going to go back to the home screen really quick. And then before you actually calculate your equation, one thing you're going to want to double check is make sure that your diagnostic is on. And that means that it'll give you the R squared value, which shows correlation and how good of a model it is. So you're going to press second catalog, and then you want to turn diagnostic on. So I'm going to come here to the inverse button so that I can press that, and it'll go to the D's. And then I'm going to scroll down until I get to diagnostic on. And I'm trying to go kind of slow because this lags a lot. There it is. So I'm going to press enter on diagnostic on, and then press enter again so that it says done. And it will not turn it on unless it says done. That's the way that you know that you got it. So then I'm going to go back to stat, and I want to calculate an exponential regression model is what it's asking for. And so I'm going to go over to calc, and then I'm going to scroll down until I get to expreg. Or if you remember from last year, expreg is 0. And so it'll pull this up for you. And then you're going to want to make sure L1 is in your X's, L2 is in your Y's. You can skip over frequency list, and then you're going to go to store reg EQ. And we want to store our regression equation in y equals. We want it to be in there for us so that it'll graph. That's going to be important in this unit as well. So for store reg EQ, I'm going to hit vars for variables, and then I want to go over to get to y variables right there. And then I'm just going to press enter on function and press enter on y1. And so that's everything I need to calculate this regression equation, so I'm going to press enter. And then it'll bring this up for you. So what I'm going to do is I'm going to copy this over so that I can put it in our slides, and then I'll show you what to do from there. Okay, so it tells you that whenever you're doing an exponential equation, it'll give you the base form of it up here. So we need a times b to the x, and then it tells you what a and b are. So if I were to write out that equation, I would have y equals a, which is 0.488, times b, which is 1.116, and then that's raised to the x power. So the x is going to be up there in the exponent. And then the other thing that I want you to look at is the r squared value. So one thing that we're going to be looking at in this unit is if it's a good equation, a good model for the data. And so I'm just going to write r squared equals 0.891. And then the main thing that you're going to want to note about this is the closer r squared is to 1, the better the model is. So if you test it out with, if you test out the data on several different regression equations, then you're going to want to choose the regression equation you get that has the r squared value the closest to 1. So then something else I want to talk about is this is the exponential regression calculator that I posted on your weekly assignment calendar. If you go on there, there's a link to it. I don't remember if I gave you guys this before, but if not, I posted it again. And so these are just some random numbers that were preloaded in here. I'm not going to type in the actual model and everything that we were doing. I just want to show you how it works. So it's on regression or exponential regression right here. And then I'm going to just click execute. And then whenever it pops up, it gives you the A value, the B value, and it also gives you the correlation coefficient. Obviously, it's different because it's a different set of data, but it gives you everything that you need to, okay, I don't know where it went, but it gives you everything that you need for the equations as well here. Okay, so we have another problem here. Sorry for all the technical difficulties, by the way. But we have another problem here, and it's asking us to find an exponential model of the data that has like the years since 1985 and the circulation of USA Today. So we're using the data to find an exponential model, which I already did for us right here. And so if we were writing out the equation, it would end up being y equals 1.43 times 1.05 to the x power. And then is it a good fit? The r squared value is 0.975, so yeah, it's a pretty good fit. And then the next question is, according to this model, what is the estimated circulation in 2002? So the first thing that you need to do with the 2002 is see how many years that is since 1985. So that's going to be 17 years, so x is going to equal 17. So then whenever I plug that in, that'll tell you what the estimated circulation in 2002 is. So it'd be like 1.43 times 1.05 to the 17th power. So we're going to go ahead and calculate that. So instead of typing it in, since you won't get like an exact answer necessarily because you would be rounding off with the like 1.05 and everything, instead of doing that, you can just come to the table, and then I'm going to go down to where x equals 17. And I'm going to look at what the y value is at that point. I'm telling y'all, this thing like lags and does all sorts of crazy stuff. But what we're looking at is x equals 17, and the y value is 3.0733. So that's what I'm going to put down. I'm just going to write 3.07, and then it's in millions, so I'm going to say 3.07 million, I think, copies of or circulation. Yeah, the circulation of USA Today in 2002, it's telling us is 3.07 million. But then if you look at the next question, it says the actual circulation was 2.6 million. And so it wants to know, how does this compare to our estimate? So our estimate was definitely high by like 500,000. So that's a pretty significant amount to be off whenever we're making an estimate. So I'm going to write that our estimate was high. And so then we want to start looking at this. And before I go to D, I do want to show another thing with this on the calculator. So whenever I asked if it's a good fit, we had the r squared value to back it up. So yeah, it was a pretty good fit. But what I also want to show you is the graph, but it's not on a screen that really shows anything right now. So the way that you can see like where all of our data is plotted and everything is to hit zoom 9. But before you do that, you're going to want to turn on your stat plot. So I hit second y equals, and I'm going to hit enter on stat plot and just press enter on because I want it to actually show the points that I entered in L1 and L2. So then I'm going to hit zoom, and I want it to be zoom stat because it's going to show our stats that we have in there, and I'm going to hit 9. and it's a little bit slow, but it is showing us like how well this fits. And for the data range that we're in, it looks like it's a pretty good fit. You can tell that at the end it starts going a little bit high, but other than that, it's a decent fit at that point. But it wants to know what other functions might model this data well. And so this is a conversation I'd love to have with y'all in class, but I guess I'll just tell you. If you think about the circulation of USA Today, and it starts in 1985, and so there was like pretty low circulation, and then it started going up, and I didn't mean for that line to be shaky, but it started going up, but then at a certain point, like, people aren't going to necessarily be buying USA Today, and it's going to start leveling off, maybe even going back down. But we're going to draw like the graph as if it's leveling off. Like, there's only so many people in the world, it can't go up forever. So if you end up having a graph that looks like this, where it levels off at the top, then if you remember from a few units ago, that's called a logistic model. So another function that would work well for this would be a logistic model. And then for why is that more reasonable in the context of this problem? It can't keep being sold forever. Like, it's going to level off at some point. You're not going to have more circulation of USA Today than you have like people in the USA. So that's why it makes more sense to use something like a logistic model. So what I'm going to do next is I'm going to come back to my calculator, which conveniently has an option for logistic regression. So I'm going to choose logistic because I still have all of my data in that I had before. And then all I have to do is come down to store regression equation, and I'm going to press vars for variables, go over to y variables, and then just press enter a couple of times to get y1 in there, and I'm going to hit calculate. So then logistic takes a little bit longer to calculate, and I believe, it doesn't give you an r-squared value, which I think is really unfortunate for these calculators, and I don't know why it doesn't give that to you. So the biggest thing with like exponential versus logistic is you kind of have to think logically to figure out which one makes more sense in the context. So that's not really the best, but in this context, this equation would make the most sense. So I'm going to copy it over as well and show you how to decipher this y equals c over blah, blah, blah. Alright, so I've got my calculator screen copied over here, and then I'm just going to write it out. So this is a logistic model for this. So you may not remember all the different stuff about logistic models, but we're going to work with it. So we would have y equals, and then c is our numerator. So the c value is 2.39. And then that's over 1 plus, and then it says a, so that's 0.711. A times e to the negative b times x power. So I'm going to put that in parentheses. Negative b, it would be like negative 0.16. Okay, so negative 0.16 and then times x. So you may not remember that much about these, I'm not sure. But it's showing you that like the carrying capacity, which would be like the most number or the highest circulation, would be like 2.39 million. Obviously, that's not exactly accurate because in 2002 it tells you it's 2.6 million. But either way, that would be like the carrying capacity, and then over all of the other stuff that we talked about a little bit, but not as much. The main number that is important is that one right there because it's showing the carrying capacity, and then you can use X to plug in a year and it'll show you the estimated circulation for that year. Okay, so then here's another example, and it's talking about the number of cable television subscribers in the US in years since 1970. And it says in A, look at the scatter plot of the data and decide on an appropriate function. So scatter plot, that's what we were talking about whenever I turned the stat plot on. So if I come back to, I'm not sure what my computer is doing. Hang on 1 second. Okay, something had popped up about my printer. Anyway, so if you come back to your calculator, then I already entered the data in here, and we just want to see a scatter plot, so I'm going to hit zoom 9 and get the zoom stat up there again. So again, I'm going to go ahead and copy this graph over so that we can talk about it. Okay, so as you may have suspected, this gives us that same like starting strong and then leveling off look, and it's kind of like an S-curve. So an appropriate function to model the data would be logistic. And so that answers question A. And then it says the data appears to be leveling off. What in the context displays the leveling off? And it's kind of the same as like the last problem. The number of cable television subscribers in the US will never be able to exceed the number of people in the US. So at some point it's going to have to level off. And then for C, looking at your equation model, what is the number to which the data will level off to? For example, like what is the carrying capacity? So now I have to actually calculate the equation. So I'm going to come back here and I'm going to go to stat calc and scroll down until I get to logistic. There we go. And I'm going to press enter there. And then I want to store my equation in Y1. So I'm going to go to store regression equation. I'm going to go to variables, over to Y variables, and just press enter twice. And then I want to calculate. So it's going to take it a second. And when it gets there, I will paste it or post it or copy it into the PowerPoint for us. Okay, so this is where we're going to be answering part C. And I need my pen back. So C. And then it gives us the equation, so we're going to go ahead and write that out first. So we have y equals our numerator, which is C, so that says 64.6 over 1 plus A, which is 20.37 times E raised to the negative B, which is 0.21 basically, times X. So that would be our equation. And then as I mentioned earlier, for carrying capacity, that's going to be that number that's in the numerator. So it would be this number. So it's going to be leveling out at 64.6 million approximately. So that just goes through an example of using a logistic function. I'm not sure if there's an online calculator. I'm going to look and see if there is and if it gives you the same equations as the actual TI-84s do, because I'm not really sure about that. But I will check on that for y'all, and if I find one, I'll put it in the assignment calendar so that you can use that. And I think that covers everything for this topic. I know that it's going to be a little bit weird this unit, so I'm going to try to do everything that I can in videos so that y'all can see what's going on. But that's about it. Sorry for endless technical difficulties tonight. Or today. Y'all are watching it in the daytime. But hopefully that will not be happening as much. But anyway, I hope you guys have a great day.